Hello, everyone. Um, Welcome back to day 61. This stream is going to be extremely short because it is raining and my network is absolutely terrible. Yeah. So I'm just going to try my best and keep it short and hopefully, you know, try and explain really well. Just a second, please. Let me quickly be right back. All right. Good. So let's say we have about 15 minutes or less, cause there is rain and network is bad. So we have to compromise, right? Tomorrow is another day. Tomorrow is another day. But today is today. Do great things today. Okay, so let's. This question is quite. It tricked me a little, right? Because if you look here, I submitted about five wrong answers, right? I mean, these answers here, they were just small mistakes that I did not see. I probably overlooked, and once I thought I got the right answer, and then he hit me with the time limit exceeded error. But that's still good. An attempt is always good. But then the editorial is available. I read through the editorial and I finally understood what the question was trying to say. So let's see what this question is all about. Given an array of integers norms, right, and an integer k, return the number of contiguous subarray where the product of all the elements in the subarray is strictly less than k, right? So here's our example. We have an input array of 10, 5, 2, 6, right? And our k integer is 100. So the number of subarrays where the product is strictly less than k is equal to 8, right? Now, how was this calculated? Well, first of all, every integer in the array, in the nums array itself, is a subarray, right? So that is 1. So every one of these is a subarray. So this is going to be 10, 5, and so on. So already we have items, so 4 subarrays at this point. Now we'll begin to, find every other subarray that is more than one item in it, that has more than one item in it, right? So we'll then look at 10 and 5. Well, that is 1. 5 and 10 and 2 is not going to work, or violates the condition. So we look at 5 and 2, 2 and 6, and then so on. So every subarray we see, for every subarray we increment a count, or we count for the output. So in this case it's going to be equal to 8. Now I'll copy this and go to the board and explain better what is happening. and which algorithm we are going to use to calculate this, to solve this problem. So Control Shift paste. Yep. So we can paste like this. And let's see. Great. So let's find the sub arrays where the products of the elements are strictly less than k. For us to do that, we are going to use a sliding window. Now, there is a technique I always use when it comes to a sliding window, especially when there are two conditions. There is a condition where we are given a particular size of window or a fixed width of window, right? And we need to operate within that window. And there is another instance where the window size is not known, right? So meaning we can expand, or we can take as much items into that particular window, right? And a window is simply a range of, between 2 points. So usually we use a left and right pointer, right? So for example, let me demonstrate something quickly before I come back to this question, right? Before I come back to this question, I will use a different example just to explain some techniques behind sliding window, right? So let's say we've been given you know a number array. I'll just use number, right? A numbers array, and we have again 10, 5. I'll just use the same example, 2, 6, right? And then we want to find the we want to find two items, right? Or a sub array of 2 items where the sum of those items is superior to k, right? K is then equal to, let's say k should be equal to 7. Now the sum of those items should be equal to 7, right? So for us to do this, right, we first of all know the size of our window, right? We want 2 items, right? So in that case, right, every operation has to include at least 2 items from the numbers array here, right? We cannot you know we cannot do we cannot find the sum of 3 items, or the sum including just 1 item in the sub array. It always has to be 2, right? And we know using a sliding window, we usually have a left and a right pointer, right? So the left and right pointer will always point at 2 items at a time, right? And then we begin to slide the left and right pointer, right? We begin to slide. Oh, my network is absolutely terrible. Jesus. So let me say that again. When we have a fixed width of window to operate with, right? In other words, if we know the length of the particular sub array that we are going to use for an operation, using a sliding window, right, we have to point we sliding window involves 2 pointers, right? Naturally, that is what sliding window is. We have a window, and a window has 2 points, right? A beginning and an end. Now the window can have a fixed width, or the window's width can vary, right? So in the case where we know the length of the sub array that we are going to use to perform a particular operation, then the we'll point the left and right pointer to make up for that particular width, right? So we know our sub array has to have a length of 2, so we need to place our left and right pointer one after the other, right? And the total amount of item within that window should be equal to 2. then we begin to slide the window, right? We begin to slide the window across the array, right? So in this case, if we're to find a sub array from the numbers array here, right? From this example, this number array here, if we're to find a sub array of length 2, right? Or a sub array with 2 items, 2 integers in it, such that the sum of those integers add up to this 7, right? We simply need to place the left pointer and the right pointer one after the other, right? And we'll begin to slide we'll begin to slide the left and right pointer across the array. So that is just an example of how, an operation like this would work, right, when it comes to a fixed size array. Now, in the case where we don't know the size of the array, right, let's say instead of us being told that there are 2 items in the nums array or in the numbers array, right, such that they add up to 7, right, we can be asked to find a set of numbers from this nums array such that they add up to 7, right? We are not told how many, but we want to know we want to find a set of numbers, right? So for us to do that, we can start now this time around we don't know the size of our window, right? So if we don't know the size of our window, we can put a left pointer here and a right pointer here, right, at the same position, and then expand the window by moving the right pointer across the array, right? Now when a condition is not met, right, we will shrink the window by simply moving the left pointer towards the right, and then expand the window by moving the right pointer towards the right. So those are the 2 basic tricks that I use to solve sliding window questions. When I know the length of my window, or when the window has a fixed width, then I put the left and right pointer at a certain position, right, to accommodate as many items within that window. Or when in the case where the size of the window is not known, then the left and right pointer will start at the same position, but the right pointer will increase to expand the window. But in the case where the condition is not is violated, right, we'll begin to shrink the window so that we can have a valid condition once again. Now for our question, right, for this question here, we don't know the size of our sub array, right? We don't know the size of the sub array. So in the case where we don't know the size of the sub array, then we need to start the 2 pointers at the same position, right, and then expand and shrink, right? Expand and shrink. Expand when the conditions are correct or when the conditions are not violated, and shrink when the conditions are violated. Hello, Michael. Okay, so let's see how we can do this. Now, this question, tricked me a little, but I read the editorial, and there was just one part that was really that stood out to me, right? Which is the calculation. Now, before we move into the sliding window problem, right? A brute force solution to this question, which I knew about but I still didn't want to use it, is to set 2 loops, right? And at the end of the day, you have a time complexity. Your algorithm will have a time complexity of O of n squared, right? So we want to set a brute force solution, right? A brute force solution will be O of n squared. Now our brute force solution will be 2 loops, right? So we'll start a for loop with, let's say, I, right? I will start at this integer here, right? And then j will also start at this position, right? And then we'll increase the in the second loop, or in the second nested loop, we'll increase every value of j, find the product, and then increment the count if the product is less than k, right? So but we are not going to do that here. But we need to understand what a subarray is first of all. Now a subarray is typically an item that is found in a larger array, right? And it's also, by definition, I think you might have come across definitions such as it's a contiguous, let me see. Well, it's simply I want to use a simpler term, right? So if I said a subarray of norms here, right? A subarray of norms can be 10, right? 10 is a subarray of norms. 5 is also a subarray of norms, right? 10 and 5 is also a subarray of norm. 10, 5, 2, right? It's also a subarray of norm. So subarray is essentially a smaller part of a larger set, right? A larger array, right? So a smaller item or a smaller set of items that are part of a bigger array. So let's take a look at this. So if we begin iterating through this norms array, we can get subarrays such as 10, right? 10, 5, 10 and 5, 2, right? 5 and 2, 10, 5 and 2, and then even 6, right? 2 and 6, 5 and 6, 5, 2, 6, 10, right? From all the way to this place, right? Is also a subarray of this array, right? So that is what we want to do. We want to find out the contiguous subarray, right? Which means the one item after the other, right? That when we multiply them, right, their product is less than k. So in our first iteration, assuming we set our left and right pointer at this position, right? Now we want to use a sliding window algorithm to solve this question. So we'll simply need a left and right pointer, and the left and right pointer have to start at the same position, right? So if our left and right pointer started here, right, it means the first item here is considered a subarray, right? So we can then check if this item, the product of this item is basically this item minus times 1, right? This item times 1, because our product initially will be set to 1. Product will be set to 1, right? So if we want to find the product of every item in the array, then we need to do product times whatever item is here, right? So our first subarray to look at is 10, right? And then we'll begin to increase or expand our window from there on if this condition is true. So the first item here is 10, and obviously 10 is still 10 itself, right? So 10 is less than k, which is equal to 100, right? So in this case, right, we'll increment our count and expand the window. Now, why do we have to expand the window? We have to expand the window because we want to accommodate as many items or subarray as much as we can, right? So in the first for the first item, we've counted 1 so far. So count should be equal plus equal 1. So I'll put the count here. I'll say count is equal to 1 at this point. So we will expand our window by moving the right pointer towards the right. Right now, our sub array will look like this. Our sub array is going to be equal to 10 and 5. Right now, the product of 10 and 5 is 50. Right, so 50 is less than k. Right, 50 is less than k, so we increment the count here. So this was going to be equal to 2. Right, let me move this from here. This is going to be equal to 2. So 50 is less than k, which is equal to 100. Then, because that condition is satisfied, we expand our window once again. So the right pointer will move towards the right, and we'll do the same thing. So our sub array is going to look like this time around: 10, 5, and then 2. Right, so 10, 5, and 2 is our new sub array. Now, is the product of every item in this sub array less than k? The product of every item here is 100. Right, so this is 50 times 2 is 100. So 100 is equal to k. It is not strictly less than k, so this is not a valid condition. Now, once a condition is violated, we do what? We shrink the window. Right, so we'll need to shrink the window at this point. So we'll move the left pointer towards the right. Now, our new sub array is going to be like this: 5 and then 2. Right, here's our new sub array. So for our new sub array, we'll find the product again. So this is going to be equal to 10. 10 is less than k, so we increment the count. Count is going to be 3. Right, so let's remove this. Count is equal to 3, and then we'll expand our window again. Right, now our right pointer will stop at this point. So we can also do this. We can say so our new sub array is going to be 5, 2, 6. Right, 5, 2, 6. The product of 5, 2, 6 is also less than k. Right, so this will increment our count once again. So our counts, let me erase this. Our counts will now be equal to 4. So our counts will now be equal to 4, and then we'll continue. Right, we'll move our left pointer once again towards this point. Right, so we'll have 2 and then 6 as our sub array. Right, 2 and 6 is less than 100. Right, it's 12. So this also passes the test. So at this point, we have 5 items. Right, now we are not done yet, so we'll still need to increment the left pointer until it's equal to the right pointer. Right, until they are at the same position. Now the item at this position is still less than the k. Right, so the count here is going to be equal to 6. Now this works, right, but there is a problem. We were just accounting for every items in the window. Right, we're shrinking and increasing the size of the window, but we did not take into account, or I did not take into account, every individual item. Right, because 5 is also a sub array of this norms array. Right, 2 is also a sub array. So far we were able to get 5 10 and 6, right, individually. But what happened to 5 and 2, right? Because at the end of the day, the result is supposed to be 8. So what what should be done to, you know, account for the individual items, or in other words, how can we affect the sub arrays that, you know, um that don't violate this condition here? Well, one way to do that is to, maybe I did not think about this while explaining this. Now I'm beginning to think about it. What if before we move our pointer, right? Before we um what if before we expand the window, we let the window shrink first before it expands, right? So here's what I mean by that. If we start from this position here, if we had the left and right pointers here, right? That's not going to work. We'll move the left pointer here, shrink the window first. No, it's not going to work. Or another way to do this is to this is going to be funny, because the product alone, finding the product itself, right, is done by using a multiplication of every item in the array. So we'll have another loop handling the product of every items in the sub array. So already that's looking like O of n squared times complexity, which is not something we want to get into, right? So we want this algorithm to be in linear time as much as we can, right? Don't worry, I know the solution, but it just hits me, right, to think about this new thing that I found. If I'm increasing the left and right pointer, right? Say I started from this position here. I started at the beginning, and I increased the left pointer up to this point, and the right pointer up to that point, and the left pointer up to this point. I can make an exception and end the loop here, right? I can make an exception and end the loop here, which means I have one more item that I didn't look at, and another one here and another one here. So individual items. And then I can use a third loop, right? A third loop to check if each of these items are less than k. And oh, sorry, like I said, my network is really terrible today. I apologize for that. Hopefully it doesn't rain tomorrow, so I can do this stream properly. So let's see how we can do that, right? So this function here calculates the sum of every item in the sub array, like as you can see here, right? I don't even need to do this, so I can just take this quick here from here, just to avoid all of those stories. So this will find the sum between every window, right? Now, if so, I can return the product, right? Let me return the product instead. So this should be returned in an integer. Or should I just give you the solution first before we try out this? I don't know. Let's just try. It's not. There's no harm in failing, right? So here's our product. So this is going to be times 1 times 1, blah blah blah. So this will find the product for within every window, right? Now our loop. Let me remove all of this here first of all. Okay, so let's do this. I'll remove everything here. I'll say product calculation, right? So if this is less than k, right? If this is less than k, right? If it's less than k, we can increment our right pointer. Now our left pointer, the left pointer has to stop right before the position where the right pointer is, right? So I can say, while left is less than right, or I can just say len of norms minus 2, because left and right will start at the same position, which is really weird for this condition here. So that loop will never run if I did it that way. Now if this is the case, right, if the product here is less than k, then we can expand our window, right? Now before we expand our window, we also need to know if k, if the right pointer is less than the length of norms, right? So if it is, then we can increment it. So right plus equal 1, and we need to count. So I'll put the count here. Let me create the count variable. Oh, count is already 0 up there, so which is good. We can say if this happens, if product is less than k, then we want to count plus equal 1, right? And yeah, otherwise if it's not, right, else if this is not the case, then we can expand the window, right? We can shrink the window. So we say right yes, so right plus equal 1, like this. All right, so at this point we found so if this and that, so they're starting at 0 0, index 0. For this out and run this one, I think we should have 6 as the result here, which means we did not count everything. If this solution is right, then left is supposed to be left. So left plus equal 1, right? So we should get 6. Oh, infinite loop. So there is a mistake here. Len of norms minus 2. How do I even know len of norms is actually while left is hold on, there's something subarray. What's the I think I must have done something wrong for norms here. I don't need to do that. Sub sum sub num is equal to this, and we can say sub num here, right? And okay, something is good. What did I do wrong? This is very funny. If right is less than num, oh, right must have reached outside the range. Okay, so What am I doing wrong now? Oh god. This is, hold on. Um sorry. I can bring back my old solution. Right? So I still want to make this solution work because I believe I believe in it so much. I think I'm emotionally attached to it. I don't know. Maybe, maybe not. Oh, sorry. I can copy this here, right? And copy this part. Okay, let me begin to clear out everything one after the other. Maybe I'm not giving the solution time to run. I think so. Don't you reckon? Okay, now that is. You see, if this will return the product, right, which is an integer. Okay, so you know what? Let's do this like this. I'm not sure what's going on, but hey, that's enough time wasted. Honestly, I can't stress on this. So I'll do this myself later on, right? But let me just show you the correct way to do this. I'll just go ahead. First of all, we need, just like in I think maximum sub array sum, right? Maximum sub array sum. Although in maximum sub array sum, we knew the size of the array, didn't we? Max sub array sum here. Max sub array sum. So you can see we first of all found, we calculated the maximum sub array, and then uh we removed the the item that does not belong in that sub array, right? And then added another new item in the window. So in this case, that same solution will work, but here is how we need to do it. So we can first of all take the let me remove all of this. Oh god. Okay. Ah, okay. That's very bad. So we can start. Let me remove the count. We can start, our pointers like this, right? The left and right pointer. We can find the product at each point, right? So the product 10 times, we will increment the product for every item in the array, right? But then how we will calculate the count is simply by the distance, by subtracting the distance the left pointer moved from, subtracting the right pointer from the left pointer, right? So here's what we need to do. And before we move the left pointer, right, we would have had a valid sub array. In other words, a sub array where the product of every item is less than k. So in the first iteration, we can have something like this, right? Our left and right pointer will be at index 0, right? Now, the product at this point here is simply going to be 10 because we want to do 10 times product here, which is 1, right? Product is set to 1 initially. So we do 10 times 1, right? And then we'll increment the right pointer again, right? Until we reach a case where, the sub array is no longer valid, right, for the condition we are looking for, then we'll have to remove one item from the sub array, right? And for us to remove one item from the sub array, we simply need to move the left pointer away from that point. In other words, we shrink the window, right? When we shrink the window, for us to remove one item from the window, right, we simply need to divide by this item, right? We divide the product by this item. The product will keep growing, right? Will keep increasing for every iteration. Here's how we're going to do the product. So for the first item, right, for the first item we will do times 10, right? Second iteration, right? Second iteration will, the right pointer will be at this position, right? So we'll still do again times 10 because this condition here is valid, right? We'll still do times 10. So this is going to be 5 times 10. This is going to be 50. As long as the product here is not superior to k, right, we'll continue incrementing our right pointer and keep the left pointer where it is, right? The left pointer will help us shrink the window once this product is superior to k. Now at this position here, right, at this position here, the product here will be times 2, so this is going to be 100, right? Now this has violated our condition, right? We then need to remove 10 from our sub array, right, our current sub array, by simply moving the left pointer away from it. Now when we move the left pointer away from that particular position, we need to remove that item from the equation, and for us to remove 10 out of 100, right, we simply need to divide it by 100. So we'll make a division each time. So when we divide this by 100, we'll still have 10 left, right? We'll remove 10 from the product, and then our left pointer has been reset. So we'll keep moving until we reach the end, right? We reach the end, so the right pointer will be at this position. Now there is a catch to this, right? For us to know how much item we I'm just waiting for connection, come back. Okay, so we update the total count by adding the number of valid sub arrays with the current window size. Now the number of valid sub arrays would have been counted with the right pointer, right? And the window size is simply the right minus left, right? Left plus 1. Now why do we do plus 1? So the current window size is right plus left, right minus left, but we do plus 1 because we started counting from 0, right? Left was at index 0, so we need to add plus 1 to make it an actual count, right? Because the first item in the array is simply a valid sub array, right? So so we update by dividing the item at this left index, at this left position. We remove 10 from this window, right? We remove 10 from this window by just dividing by 10 and then incrementing the left pointer to the next item in the window. Now to calculate the current count, we simply do right minus left plus 1, and that's about it, I think, for now. I'm going to continue, right, with this particular method that I was trying to use here. I need to find a way to make this work. I mean, this, in my opinion, should work, right? But there's no enough time to waste on this stream, so I would suggest everybody that was here to read the question, read the solution, go through the editorial and understand it better before you can attempt solving it, right? If you that's if you don't know how to solve the question. Okay, and it still doesn't hurt to understand, to see the editorial and understand it anyway. My stream has come to an end. Sorry, my network keeps going off and on, so I'll need to end this for now. Hopefully, I come back tomorrow with a much better explanation to this question than I did today. And as always, stay coding, and I'll see you guys tomorrow.